today I will present driving further activity, which is a modeling activity. We'll be modeling with real data, looking at the driving distances on men's and women's golf tours. The activity can be found on the Texas Instrument Education Australia website. And if you look Senior Curriculum Inspirations and Victoria, it is under General Mathematics Year 11. So you will see Victoria driving further by Texas Instruments, and it has the description of the activity, and also there are the files associated with the activity. So basically there are two files. One is student activity and the other one is teacher notes and answers. So that's how they look. Student activity here, it has time, it's about 30 minutes, and teacher's notes and answers is also with all the hints and answers for the teachers. This is designed for TI-nspire, CAS or non-CAS, and for year 10, 11, about 30 minutes. You will be able to see the data, which is actually driving distances, PGA, that's men's average driving distances measured in meters. That's the real data, which was collected from 1990 to 2009. And similarly, we have LPGA women's tour and average driving distances for the same number of years, 1992 to 2009. So now you might think how you want to manage this activity in your class. You might prepare the TNS file and enter those activities, year here and PGA, LPGA for the students, and send it to them and share, or the students will enter data themselves. Again, that's something to think about after you tried what was happening here. So these are the questions which are on students' handout. Plot the graphs, and it suggests plot two separate graphs. Think, is a linear model appropriate for either of these data sets? Then find the equation of the line of best fit using the linear least squares regression line. And then we try to do some predictions, estimate the average driving distances for both tours in 2018, then see how would those driving distances, in which year we would reach those values. Here we are in yards because that's what the website says, and then we can use conversion assistance to change in between. Comment how realistic the predictions are, and there are also links to the website when students can find the current data, 2018 and 19, and see how well the model predicts. And also there is a question, will driving distances grow without bounds? So if I go to the calculator, I have on this listen spreadsheets page a year, and all the data in years from 1992 to 2009 are entered, and we enter PGA, so it's men's driving distances and women's average driving distances. So the next one is actually looking at the data. I believe everyone would know how to do it. We get the pin graph, and we put a year here, and then we enter PGA. So we can see that the data is pretty linear here, and then it starts curving a bit. And if we do a similar thing for the women's one, so if I have a year here, but this time I will put women's one, yeah, it is looking a bit like that. So now we can fit the regression line for women, and here we have the regression line. Where do we get it? We get it from analyze regression, and we just use linear regression. It's hide here because I already have it, but if I don't, then we get the regression line. So if I go to men's, we go menu, analyze regression, and we'll use this one. So we get the gradient and we get the y-intercept. If we wish to see the correlation coefficient, here I just put both on one graph to see how they compare. They look nearly parallel, but they actually not, because one gradient is 1.5, one is 1.8, so there are slight differences. Now, if we wish to find the correlation coefficient R, we should do the same linear regression, but in the calculator screen. So as you see, I've got PGA here. So the correlation coefficient is 0.98, which is really a strong linear correlation. And for women here, LPGA, the correlation coefficient is a bit less, is 0.94, which still shows the quite strong correlation. So now to do the predictions, if I from here go up, just to show that the regression line is saved. Whenever you do the regression lines get saved. This time it's saved as F3, so we can use F3 in 2018 to find the prediction in 2018, which will give us 282.5. If we wish to find in which year the driving distance will be 310 meters, we solve using also F3 next equals to get the year, which is a while from here. And the same can be done for this one, which was PGA, so it's men, and this one was saved in F4, so I can do the prediction for men and compare. If I go back to the PowerPoint, I took this screenshot from the website where the link is given to this website, and this is for women. Average driving distance, as you can see, 2018. Now, those distances on the website are actually in yards because that's American website, so the distances are in yards. So if I want to see how accurate this prediction is, I need to change the yards to meters. So the calculator has the feature, if we press here and number 3, so it's book number 3, it's called Conversion Assistant. And if I choose Conversion Assistant, I'll be changing length, and I want to change length from, and if I scroll down, I need to find, if you scroll down, you can find yards, and we change length from yards to meters, which I already did here. So the prediction, as we can see, is here under a bit as compared to what it actually is. The next question is about looking whether the men and women driving distances, whether they will ever be equal. If we solve those two equations, those two linear models, we get the year 1893, which of course is a bit ridiculous. And if I want to solve it given that the year is greater than 1992, it gives me false. Now, if I sketch those two graphs and I go from 1800 to 2040, I can see that those two linear models intersect in 1890, which of course is not in our data set, so we're looking at big extrapolation here. And if we look from 1992 to about 2040, we can clearly see that those lines are actually getting a bit wider because the gradient for men's tour is bigger. So there is a lot of scope here for students' discussions. So will the driving distances grow without bounds? And students should discuss that. How are we predicting if we are actually doing predictions for the future, which is outside the original data set? So we're looking at the extrapolation and how realistic the year 18 something is, of course, when the two graphs intersect. So that's a lot of real data where students can actually refer to some real-life situation and think critically. If you go to the student handout, there is also an extension which is looking at Flinders Golf Course and has some questions. It does require a bit of the knowledge about golf, I think, to understand what this question is about. So it is a really nice activity, real-life data, regression models, modeling, predicting, and looking critically how good the models fit the real data. Thank you, and I encourage you to use this activity with your class.